A train leaves Philadelphia at 1 p.m. It's traveling at 65 miles per hour. Another train leaves Denver at 4. Say, you need some paper? And that's how some kids feel about problem solving. They think, what in the world did she just say? So we're going to kind of talk about how we teach them, what we teach them, and then how you can help us. So here's your first test question. What is problem solving? Give you a second to look through. Is it getting the right answer? Using logical reasoning to solve problems? Going through a step-by-step process to get the correct answer? Guess and hope the answer is right. Any takers? Yes, ma'am. B, C. C. I love that you say C. You know what? You're going to be so surprised. It's so not about A.
I know.
It's not about A, and this is so what we grew up with. I mean, we as in, our teachers taught us, here are the steps, this is what you do, and then you box your answer and you say what we're talking about and we're done. And that's not what we teach kids at all anymore. We talk about B, what is logical, what makes the most sense, and to help them solve problems. Here in Clear Creek, we teach the 4 blocks, what we consider the 4 blocks of problem solving, and we talk about that base. Understanding the problem first. We really focus on, we're not going to leave this problem until you understand exactly what's being asked of you. And then we're going to make a plan to carry it out. We're going to make a plan, we're going to carry it out. And then the last thing we do is we talk about, is it a reasonable answer? So, in understanding a problem, we ask kids to imagine the situation first. And I always say, do you have that picture? Are you there? No matter what they're asking, are you at that grocery store? Are you on that farm? Whatever the problem is. Then what do you notice? And what do you see? What do you know for sure? And we're going to talk that through in a second. Are there any special conditions, rules, or tricks that the problem is telling you up front? And then does it remind you of another situation? Do you have a schema of some other problem you've already worked that you can apply this to? So, in your green basket, you have some coins. And you're going to work this problem. So as teachers, we give a kid a problem, we talk it through, we walk around and see, what do you need to know before you can get started?
So what do you know for absolutely sure from this problem? What do you know for sure?
You have $1.
What are some things that you need to know in order to do this problem?
How much is the coin worth?
The coin value. You need to be able to know what the brown coin is called, how much it's worth, what the big silver one is, how much it's worth, what the faces are. How about this one?
When you put the coins together, what do you need to be able to do?
Shane has $1. How much is $1 worth?
You start with
100 cents.
If you don't know that, you're lost.
Kids will go, $1.
Mm-hmm.
Oh,
Yes.
I was going to do that, but then they said they had
Ma'am?
coins.
Hang on.
Did he discover he has only $1 worth of coins in the vault?
No, look at he ended up with all the glitter.
See that it leaves it open. And here's the other thing we talked about is what's the right answer. It would be hard, but each one of you probably has a very different answer that is all correct in some way or another. So you have to make a plan. We ask the kids, make a plan. What representations or pictures can you use to help you? What problem-solving strategies will help you the most in this situation? And in the second grade, we focus on 4 problem-solving strategies. Drawing a picture, acting it out, looking for a pattern, and guessing and checking. Kids can do this all the time. Draw a picture. Draw out those coins. In this particular case with the money, having those coins is invaluable to them. to actually move them and manipulate them. This is the last grade where we really focus on acting it out. Actually pulling out your dolls and your Legos and your miniature animals to physically act out that problem. Looking for a problem, and in a minute we're going to visit the STAR website where you'll see how valuable looking for that pattern is. And lastly, guessing and checking. So when kids carry out a plan, we want to predict what the answer might be. Before they even get started, we ask them to predict, okay, what's going to happen here? How much do you think it's going to be? Because in essence, you want to get close to that prediction at the end after you work it through. Make a picture, work on the problem using some kind of strategy, one of those 4 strategies, and then we really start probing them. Why did you solve it the way you did? Can you think of a different way to solve it, a more efficient way to solve it? I mean, some kids may take 100 pennies and they are absolutely correct. That is a bowl that's $1. But is there a more efficient way to do that? They could have 10 dimes in their hand. You keep pushing them and pressing them to think outside that box of what they already know. Some people already know that 100 pennies is $1. But where can I take you further in your thinking? Do you have something to add? No. It seemed like it. Okay. Okay. One of the things that we try to get kids to do is read all the way through, make their prediction. So in this case, Mrs. Shoemaker went to the library and checked out 14 fiction books. So I always tell my kids, do you see yourself? Are you in that library? Do you have 14 books in your hand? And then 7 nonfiction books. How many books did Ms. Shoemaker get all together? So I always say, you have those 14 books in your hand. Are you going to have more than 14 when you put those 7 there? Or are you going to have less? Am I going to walk away with a large number? Or am I going to walk away with a small number? All of those things, before they even start any of the math, you kind of talk them through. A lot of times, the kids will look at 14 and 7, add them together, and not even consider any other option. That's when we say, does your answer make sense? Some may have subtracted, okay, I have 7 books. Well, can that really be possible if you're just holding 14 and she's getting 7 more? Does your solution answer the question to the problem? And a lot of times they'll come up with an answer, but it's not the one that the problem is asking, because the problem will throw in extraneous information that was really unnecessary for the child. Okay, your second problem. You have manipulatives. Charlie brought 24 cupcakes for her birthday. After she passed out the cupcakes to her classmates, there were 7 left. How many, I'm sorry, 5 left. How many cupcakes did she pass out? It seems very simple to us that there are going to be less than 24. But so often kids would say 24 and 5, that's 29 cupcakes. And then we say, well, does that make sense? Because the kids all ate one. So we would say, get out your manipulatives. Let's get those 24 cupcakes. Put these 5 off to the side. This is what's left over. So how many were eaten? Or how many kids are there in the class? Are there any questions? Okay. Why problem solving is so important in the lower grades and beyond are it fosters logical reasoning. And that's why a lot of times we don't just dive into the question, start reading it and go through. We make them stop, put themselves in that scenario, make sure that they understand the information. It encourages creativity and innovation. It promotes teamwork and collaboration. I would say 85 to 90% of everything we do in problem solving is together. They are collaborating. Those kids are able to affirm one another and be affiliated with their group and really bounce those ideas off of one another. It develops good communication skills. Your kids are talking math. They're mathing it up, as one of the second graders said. They're using those math words. It's part of real life. You know, we don't just say, oh, okay, 14 plus 7. That means nothing, but when we put it in real life, 14 books, she went and checked out 7 more, then it makes sense. And lastly, and not something I want to focus on, but your kids will be tested on the STAR test in 3rd grade, the spring of 3rd grade. So we're going to take you to the 3rd grade, the website, the TA website of STAR, and we're going to look at just some sample questions that might make you or help you see where it is your kids are headed. This is a good question. Lynn and Dennis have the same amount of money. Lynn has the bills and coins shown below. So before your kids would even tackle this problem, as a teacher, we would cover up all of this, and they would just look at this. So what do they need to know?
Money value, yeah.
Not just money value.
How much you have?
How are they going to get that sum? Your kids have to know how to count on. That is a very hard concept for them. If you give them a quarter and then you slide this next to it, they have to know the value of these 2 coins and then be able to count by tens from 25 to 35 to 45 and so on. Then after they get this answer, they have to go down and count all of those to find an equivalent amount. They have to understand what even equivalent means. So that's why we're giving them those coins, and we're encouraging you all to do the same thing. This one is on fractions. I like how they shade the 3rd because that's not the answer. But a lot of kids won't even read through it. It's a cracker, and it talks about how much of the cracker does Bobby have left, or what, that's how much he has left. What did he eat?
And for those of you who have kids in older grades who've taken the tax test before, it's just the opposite. They always are talking about the shaded part. Now they're talking about the unshaded part.
Number 4, I wanted to kind of point out to you, it's an open-ended question. Mr. Garza has 3 kinds of animals on the farm. He has 6 dogs. He has twice as many cows as dogs. He has 3 times as many sheep as cows. How many sheep does Mr. Garza have? So they're multiplying that out. They have to know about, basic stuff, animals on farms. And then the biggest thing is, here's this whole area, work the problem, and then go bubble it on your form. So there's not even an answer choice. This is
multi-step problem.
Multi-step. Thank you.
Got to figure out one thing before they can get to the answer to the next part. So.
I mentioned earlier about growing patterns. There's a great example of a growing pattern that's shown on the test. This table, it's an input-output table. So it gives you 2 mornings and the amount of milk and so on and so forth. And then here's your answer that you're looking for, and they skip right past number 4 for all of those kids who want to put 48. There's the answer right there for you. So we really have to talk to them about, it's not just about math anymore. It's about also learning how to work the problems and what it's really asking you. It's asking you about the 5 mornings and not the 4 mornings. If you stop there for 1 second, because I like this. They have the figure that has 5 vertices and 5 faces. It's all those math terms. I mean, they're already bombarded with a lot of information, and they have to remember what's a vertice as opposed to what's a face. There's number lines and fractions. This particular problem talks about the height of plants, and Ms. Shoemaker did a really great job earlier that I forgot about. It talks about measuring with a ruler. In this problem it says which 2 plants have a total height of 23 centimeters. So they have to, you tell me, what do they have to do? Oh,
We have
come.
to measure the plants.
Measure the
Each
plants.
one, and then they have to figure out which two are gonna add up to 23 centimeters.
Okay, and in this case, they have a broken ruler that starts at 3. So then
They
what?
have to add the number that they don't have on their ruler to the length that they get on the plant.
Yeah, a lot of times what they'll do is they'll show you a ruler. It doesn't start at 0. It will start at 1, or it'll be cracked on one end and it'll start at 3, and they'll measure 3 to 28. Well, the answer's not 28. They have to think about where they started from. So it's that deep thinking. And in a minute, we're going to get to a slide that says, what can you do? And these are some of the things that you can do. Just point out to your kids. And this is perimeter. I'm sorry. This is perimeter. It shows the ribbon or the piece of cloth and how Maria cut out just a section. And they will oftentimes add these two numbers together and fail to remember that perimeter means all the way around those sides. So it's just another one of those math terms that they have to know what that perimeter means. Chime in at any time. Thermometers. This problem talks about, gives you a graph up top, and then down below gives you a pictograph, so they have to translate the information from the top graph into the pictograph down below to get their answer.
These problems.
Which 2 parking lots had a difference of 3 blue cars? So they're combining the 2 parking lots and then having to find a difference, and knowing that the word difference means to subtract. And we're done. Ah, breathe.
Is that available to us?
Yeah, it's there, and the website's in your packet too. In your green basket, you have some squares to work the next problem. There are 4 square tables at the Rainforest Cafe. Each table seats 1 friend on each side. 10 friends want to sit together. It's a real life problem when you go to a restaurant. They will show me both of these, and there will be a lot of other choices, but we'll have to really talk through it. Now, as adults, it's pretty simple for us. We visit restaurants. We've been in this situation. So then my other student wants to do it this way. Thank you. Whoops. And then we have to go through together to decide. And then we'll go through and we'll say 2, 3, 4, 5, 6, 7, 8, 9, 10. And actually, if I were teaching to students, they would come up and they would do this. And they would say, well, there are my 10 friends. And then I would have someone else come up and they would say, well, those are my 8 friends, but we can sit really close together. And they will say, well, all we did was pull up another chair. And you know what I say? You're absolutely correct. Because I didn't say they couldn't pull up a chair. I mean, there will be kids who will think outside that traditional line. And here's the thing, that is what we encourage all day long in the class. Because I'm going to say, okay, you're right. And then you're going to have another student off to the side say, but wait a second. And then there's this whole deep discussion that's taking place about math. Looking for a pattern is another kind of example, and I think we're getting close to the end here. On Monday, Jill reads 8, Tuesday 10, Wednesday 12 pages. If it continues, what happens by Friday?
16 pages.
Okay, so how can you help? And there are tons of ways that you can help. One of the best things you can do is when you're shopping with your kids, just talk to them. I'm guilty. I promise I have my list of 5 things. I ride through the store, I'm like, they're all in, let's go. If you're like me, we buy 3 gallons of milk at a time. There is no such thing as the half gallon being bought, a quart, a pint. These are things that you can help with. Even if you just stop and say, hey, have you ever seen what a pint is? Or, I mean, not many of us buy that. So talking about those different quantities, talking about the difference between liters and milliliters, ounces, fluid ounces. I mean, how much is a can of beans? 12 fluid ounces. That seems very abstract. I know that's even very hard for us to think about. If I said, in your washing detergent, your liquid detergent, how many fluid ounces are there? You might have to go, ooh, I don't really know. Oh, come on, I knew it was 64 too. But your kid doesn't know. I mean, they are very like, I don't know. So shopping is a good thing. Seeing if something is truly on sale, if it really is a value, is another great thing to talk to your kids about. One of the things at home that we were just talking about is when you take a gallon of water, you know, how much do you think it's going to fill up the bathtub? You'd be surprised. Some kids think like, oh, that's going to do it. I'm going to bathe. And then it barely covers the bottom. So all of those real life experiences are what we're encouraging you to do. We can bring in containers here at school, but there just aren't enough containers and space to really be able to show them a lot of different things. When you're cooking with them, you know, definitely the measuring tools, pitchers that have fluid ounces on one side and liters on the other, just to see how very close they are. And hopefully your kids will say, why do we have 2 different units of measure? When you're cooking, if it says 2 tablespoons and you only have a half a tablespoon, how is it we're going to solve this? You know, what are we going to have to do to figure that out? And that happens at my house because we lose all kinds of things. Crafts, when you're sewing, measuring, and really showing them that most rulers do start at a 0. They often think it starts at 1. And then showing them even where the half is, talking to them about what a half would look like. Dads in the garage, or moms, in my case, in the garage. I mean, you get out that whole socket set and what 5/16 and, you know, all of those different fractional parts and pieces. And then ask those deep questions to them. If you'll just talk to them. And we know you do. I mean, you're here because you care and you really want to help them. But just asking them those kind of questions.
And you have a page that has questions on it that you
Oh, I'm sorry. Yes, there is a sheet.
It's a separate handout. If you didn't get
Thank
that.
you. And that kind of gives you an idea of all of those scaffolding questions that you can ask them. One of the best things is the catalog ads. You know, I'm going to give you $10 to go to Walmart. What are you going to buy? What can you buy? How much more do you need to buy what you really want? Those kind of things. And collections are great for kids at this age. Get a box of their collections, their Legos, their rocks, or toothpicks, or whatever, and talk to them about how many are on your base, what's the perimeter, what's the length, what's the width, let's measure it, let's sort them. How can you sort them? And then there are 4 websites here, and we have them up on these computers if you want to look at them. It's in your packet. These are great sites for kids.